Welcome to a lesson, Dr. Powell. Let's take a look at how we can rotate a graph in its equation. Supposing we are looking at an ellipse and this equation of the ellipse, let's rotate this equation by 45 degrees counterclockwise. So let's think about this part of the equation as being kind of like a function. It's an expression in x and y. This is like f of xy is equal to this expression. What we're doing is we're looking at what which x and y put into this expression output 1. So that's kind of like saying, okay, this is f of xy is equal to 1, and we're looking at all pairs xy that actually make that work to be equal to 1. All right, so that's what we can kind of think about this equation as. xy, the input, is, you can think of it as a vector or a coordinate in the plane. So maybe you're like right here, xy. So what we want to be able to do is we want to be able to put in we want to be able to put in points in the rotated figure, and we want those points to satisfy an equation. And then they will be, and we want them to be the solutions to the equation. Because remember that a graph is just a picture of solutions to an equation. So let's start with a point on the graph that we want to be the solutions for, and let's build the equation up that'll have it as a solution. So what we do, we can reuse the fact that f of xy is equal to 1. We know is a well-working equation that gives an ellipse, and let's use that. So how we're going to use it is we pick a point on our ellipse, and then what we do is we take it back 45. So we have to take it back 45 to be in the original scheme of things here with the original ellipse. And we want it to, so 45 degrees ago, or pi-fourths ago, we want the point to have satisfied the elliptical equation originally. That's kind of the idea. So if we want the xy we're plugging in to do something here, the xy that we plug in, let's look at where it was pi-fourths or 45 degrees ago and say that that will satisfy the equation. So the xy we picked will satisfy this new equation. And the effect, if we keep on doing it 45 degrees ago all the way around, we actually get a picture of the ellipse rotated by 45 degrees in a counterclockwise. But in the equation itself, this xy, we're going to replace this xy with a coordinate with the image. So think of xy as a vector. We're going to replace it as with the vector that's that's the rotated version of xy, but pi-force clockwise, backwards. So what you plug in is always backwards here from the effect that you want. Okay, so what we're plugging is xy, and what we're going to do is we're going to take it backwards pi-force. How do we take it backwards pi-force? We can do that via a complex multiplication, because multiplication by a complex number rotates, and especially if we make sure that the length of that complex number is 1. Notice this is just like a coordinate on the unit circle. Coordinates on the unit circle have length 1 away from the origin, so that's perfect. And we express it as a complex number with an imaginary part. We perform the multiplication. We get this right here. We easily can take the f plus l for the real part and the o plus I for the imaginary part here. Okay, so this xy turns out, but we're just going to take the real part and the imaginary part as in coordinates here. So this xy will rotate back pi-force to be in this coordinate right here. Notice that each entry has like an expression with like an x plus a y or something like that. And so what we're going to do is we're going to take this this coordinate pair and plug it into this function, meaning in particular, so this guy will replace or go in this slot, and this one will go in that slot. And that's essentially our equation. So let's do that. So we replace x with this. So there's a replacement, replace y with that. There's a replacement in the original equation. And we simplify, do a few things, and we eventually get this. And if you were to graph this, on Desmos or somewhere else, you'll actually can verify that it is the ellipse that's been rotated by 45 degrees in a counterclockwise direction. Thanks for watching.